So yesterday we talked about fusion, and we talked about what happens when two atoms come together and create a new element. Now we're going to talk about radiation, and radiation is a little bit different. It's actually quite the opposite. So radiation is the movement of energy from one location to another location. Usually now, there are two main types of radiation. There is ionizing and there is non-ionizing. So something to really think about is that, unsurprisingly, ionizing radiation creates ions. Ionizing radiation has, well, it actually takes a very specific amount of energy to create an ion, which ionizing radiation has. And this is important to understand because a lot of things have energy, but in order to create an ion from one specific atom, you need to have an incredible amount of energy. So we're going to talk about the differences between non-ionizing and ionizing radiation for a few minutes here. So the first of all is that in non-ionizing radiation, there are a couple of different types. There are radio waves, which generally come from something that we call radio towers. And you've seen those, outside by radio stations, like WTMJ4 is an example, on Capitol Drive. Okay. But then there's also the microwave, which an example of a microwave would clearly be a microwave. And that's also non-ionizing. Now, in between there is the Wi-Fi. So that's the Wi-Fi symbol right there. The Wi-Fi is on the tail end of radio waves and on the beginning end of microwaves. So it's the same. It's the smallest energy of radio waves and the greatest energy of microwaves. And it's non-ionizing, and that's okay. And then we have infrared. Radiation. And an example of that would be the way that the remote control works when it turns the TV on. If you push the button, the on-off button, a beam of energy that happens to be infrared is projected to the TV, and when the TV picks it up, it translates that energy into turning the TV on or off. And then lastly, we have visible light radiation. Like there. And so visible light radiation is essentially basically light waves that are detected by our eyes, and we detect them by our eyes. We're able to then convert them to colors and objects and things like that. Non-ionizing radiation is, I don't want to say harmless, but it doesn't necessarily cause a problem. So I'm going to say, yeah, harmless in the right amounts. For example, if I shine a beam of light from a flashlight on you, it won't bother you. But if I turn that light up to, like, I don't know, LED, and it's really, really intense, it might bother your eyes a little bit, maybe give you a headache. So that's the type of harmless that I'm talking about. The other type of radiation is ionizing radiation, and we have a couple of things that we need to keep track of there. We have X-rays, which is that, and then we have other types of intense radiation like alpha, decay, beta decay, and gamma radiation. And examples of those are here, here, and here. The pictures don't necessarily match up with what they do, but we have an atomic bomb, we have a nuclear power plant, and we have something called Fiestaware. And Fiestaware is actually a type of pottery that was made in the 1950s, and it was painted with a glaze that had some uranium ore in it. And as a result of that, the plates themselves are actually a little bit radioactive. Are they safe to eat off of? Yeah, sure. But if the glaze is cracked, then they become less safe. I wouldn't necessarily. I don't know that I would necessarily like put all of my food in them, and but on a rare occasion, perhaps. But again, that's called Fiestaware. Now, the types of ionizing radiation that we are going to focus on, and I've already kind of mentioned them. There are three types. Okay, so there are alpha decay, and the symbol for that looks something like that. It's like a backwards fish. And alpha decay gives off positively charged alpha particles. So they're positively charged, and we'll talk about what that means in a second. And then we would have beta decay, and the symbol for that is like a bee with a tail on it like that. And beta decay gives off negatively charged electrons. And then we have gamma decay, or gamma radiation, and the symbol for that would be like an upside down fish, I guess, and that gives off photons. That gives off light particles, which are called photons. Okay, so we're going to have a little bit more time talking about each of these individually. So again, alpha decay, remember its symbol looks something like that. Okay, alpha decay is really defined as an alpha particle is a nucleus of a helium atom that is emitted or given off from the nucleus. Of an unstable atom. Some things to be of note. There are 2 protons and 2 neutrons in one alpha particle, and the entire alpha particle is positively charged. Okay, so if I'm looking over here, we see that helium has a mass number of 4 and an atomic number of 2. So the 2 for the atomic number is showing me the number of protons, which is here and here. And then if we take 4 minus 2 to get the number of neutrons, those are there and there. So this is an example of an alpha particle, which is why it's referred to as the nucleus of a helium atom. Now, alpha decay example might look something like this. If I take uranium, which has a mass number of 238 and 92 is its atomic number, and I say that it is going to go through alpha decay. When it goes through alpha decay, one of the things that it's going to give off is it's going to give off a helium nucleus, and then it's going to give off a new element, or then what's going to be left, rather, is the element thorium. Okay? Now, the element thorium is going to have a mass number of 234 and an atomic number of 90. So the end product of alpha decay is a new element and a helium nucleus. That's important to know. Okay. The other type of decay that we are going to be working with is beta decay. Now, beta decay, what happens in beta decay, this one is by far the trickiest, in my opinion, to keep track of. So beta decay, I'm going to try to do the best I can to describe it, takes place when a neutron, oh boy, I should spell it right though, in the nucleus of the atom well, how about this? In the nucleus of an unstable atom splits into a proton and an electron. Okay, so that's what happens. Now, the result is a proton that stays in the nucleus and a high energy electron that is emitted or given off. The high energy electron, which we're going to refer to as the beta particle, is released or given off from the nucleus. The beta particle is negatively charged,